Good morning, children. Stay safely at home. Now today I am starting the modern electricity unit, and I am starting with the photoelectric effect. All right. Now photoelectric effect, if you want to understand, then we have to refer to the experiment that performed by Hertz first. Okay, and Hertz first experimentally established the concept of photoelectric effect. Now in the Hertz experiment, what he did, he take a discharge tube. Alright, discharge tube means here you see there are two metal plates, and these two metal plates are connected to a battery. So here you see this metal plate, it is connected to the negative terminal of the battery, and this one is connected to the positive terminal of a battery. So this plate, if I name it as, suppose it is plate P1 and it is plate P2, then you see P1 is negative potential and P2 at positive potential. But one thing you observe, that there is a gap between the two plates. Okay. Now Hertz performed the experiment that ultraviolet light allowed to fall on the negatively charged electrode. Then he found that for certain frequency of the incident light, that the galvanometer connected, it deflects and it gives the existence of electric current. Alright. So the question arises that although there is a gap in the circuit, then how the electric current is formed. Okay. So how it is formed? Hertz explained that when the ultraviolet light is falling on the negative plate, then electrons are emitted from the plate. Okay, electrons are emitted, and as it is positive plate, so electron gets attracted by the positive plate and they reach the positive plate. Then they, under the influence of the battery, what they do, they complete the whole circuit, and an electric current is obtained in the outer circuit. Alright. So this phenomena of emission of electron from a metal surface under the effect of light is known as photoelectric effect. Alright. So you have to learn the definition of photoelectric effect. So again I repeat, what is photoelectric effect? The phenomenon of emission of electrons from metal surface under the effect of light. You see, when the ultraviolet light is falling on the plate, then only electrons are emitted and you are getting a current in the outer circuit. So this is called the photoelectric effect, and the current you are getting in the outer circuit, that is known as photoelectric current, and the electrons they are coming out, they are also named as photoelectrons. Now Hertz and Leonard jointly did one experiment and studied the various effects of this photoelectric effect. Alright. So we have to know about the Hertz and Leonard experiment. Now Hertz and Leonard experiment, what are the different apparatus that is used in the Hertz and Leonard experiment? First is a vacuum tube, which is having a window through which light can enter into it. Okay. So you see, this is the vacuum tube. There is a window through which light can enter and fall on the metal plate P1, and there is another metal plate P2 kept in front of it. So it has two terminals. Then you see the next important part of the experiment is this one. This is a commutator. You see, there are four keys at the four sides of a square. Alright. And there are four terminals. Okay. This is known as the commutator. What commutator can do? Commutator can change the direction of current in the circuit. Alright. Now here, what is the purpose of this commutator here? To change the polarity of P1 and P2. Alright, and remember that always whenever we join a commutator, we connect the original circuit at the diagonally opposite corner. Okay, so you see here the diagonally opposite corner is these two. Okay, so what you have to do, you have to connect this P1 with this terminal and P2 with this terminal. Is that clear? Diagonally opposite terminals are connected. So that's why I have not drawn the circuit. I am not teaching. I am showing you how to join the circuit. You should not mug it up. You understand it and then you should join the circuit. Alright? Then there will be no problem in answering or drawing the circuit. So here you see these two diagonally opposite corner when you are joining, then you want to measure, or rather not you, Hearts and Leonard measured the photoelectric current in the circuit. So if you want to measure the current in the circuit, then you need an ammeter. But as the amount of photoelectric current is not very large, so that's why what you have to do, you have to take a microammeter. Okay, what you have taken? Microammeter or milliammeter, but not an ammeter. Why? Because photoelectric current are very small. So you see the ammeter is joined in series, and how you have joined it? The original for discharge tube diagonally opposite corner of the commutator. Alright, now you need to connect one battery also. But in this one, Hearts and Leonard experiment, what they did, not only they changed the polarity of P1 and P2, they also changed the potential applied across the two plates. Alright, so that's why for that purpose we use another apparatus that is known as the potential divider. Alright, just look at it. What is it? That with a battery, a variable resistance is connected. This arrow indicates that it is a variable resistance. Alright, so if you change the point of this connection, this arrow means you can slide it. Alright, so what will happen? The potential across these 2 points, it will change. Is that clear? So what is it? It is a potential divider. And what is the purpose of the potential divider? Potential divider, by the potential divider, we can change the amount of potential applied across the two electrodes P1 and P2. So you see this potential divider, you have to connect it to the other two diagonally opposite terminals. So these two are left. So you see here I have jumped this point. So this is the way you have to join the circuit. Okay, this is one terminal, this is one terminal of the potential divider that you have to connect to the commutator. How? Again, the leftover diagonally opposite corner. Clear? Now, not only we have to apply the different amount of potential, variable potential across P1 and P2, also we have to measure how much potential is applied across P1 and P2. So you know voltmeter can measure. So that's why a voltmeter is connected across these 2 points so that you can measure how much potential is applied across P1 and P2. Alright, now remember that whenever there are 4 gaps, so if I name it 1, 2, 3, 4, remember whenever we put the gap or we join the gap, then we join the gaps of opposite side. Never we join the gap of two adjacent side. That is the way of using a commutator. Alright. What is the first point related with commutator? I told that always you have to join the potential divider across two diagonally opposite corner, and then you join the discharge tube across the other two diagonally opposite corner. This is the first point. Then second point, when you will join the gaps, then you should join the opposite side gaps. Is that clear? Now if you join, so here you see, if you join the gaps of 1 and 3, just you understand it, then what is happening? If you join the gaps, suppose 1 and 3 you have joined, then what is happening? Just understand it. The current is coming through this positive terminal, it is going here, then coming here. Okay, just follow my finger or follow the tip of the pen. From the positive terminal of the battery, current is coming, it is going here, it is crossing, then this is joined. So it will come here and then the current will come here. What does it mean? P1 is becoming positively charged. Alright. Then P1 is positively charged, then you just follow the negative terminal, it is coming here, then it will come here, the current, it will come here, then it will go there, then you see coming to P2. Means if you join 1 and 3, then what will happen? P1 will be positively charged and P2 will be negatively charged. Is that clear? Now suppose you are joining 2 and 4. As I said that whenever you will join the commutator, always you will join the gap, opposite side gap, not the adjacent gap. So if one join 2 and 4, then you see what is happening. From the positive terminal, current is coming out, it is going here, then it is coming here. Is that clear? Then what is happening when it is coming here? There is a gap. Is that clear? So if you consider the negative terminal, the negative terminal current is coming here, it is coming here. So P1 is becoming negatively charged. Is that clear? And what is happening to P2? Just you see. From positive terminal, current is coming, then it is coming here. This side it cannot go, so this side it will come and then it will come to P2. So when you are joining 2 and 4, then what is happening? P1 is getting negatively charged potential, negative potential, and P2 will be positive potential. Is that clear? So you see, by the commutator, not only you can change the amount of potential applied across P1 and P2, you can change the polarity of P1 and P2. So once again I am repeating, if you join the gap 1 and 3, so I am writing here, when 1 and 3 joined, then what is happening? P1 is positively charged and P2 becoming negatively charged. Is that clear? And when you are joining 2 and 4, when you join 2 and 4, then what is happening? P1 becoming negative and P2 becoming positive. Is that clear? So this is the main structure of the Hertz and Leonard's experiment. And then what they did, first they studied, they allowed the different amount of, means the light of different intensity or light are allowed to fall on the metal plate P1. Is that clear? Then they perform the experiment that first P1 is made negative with respect to P2. Alright. And then slowly negativity of P1 decreases. Means the voltage is increases. P1 is becoming less negative. Then P1 will become positive with respect to P2. Is that clear? That's the way they have done the experiment. And not only that, they have also changed the intensity of the incident light as well as frequency of the incident light and studied the various aspects of the photoelectric effect. That one by one I am discussing now. Now first they studied the dependence of the photoelectric current upon the intensity of light. So as I said that what they have done, join 2 and 4 and then P1 is becoming negative, P2 is becoming positive. Then slowly what they have done, they have increases the voltage across P1 and P2. Means after some time they have done this, that in negativity of P1 decreases with time and means P1 becomes more positive with respect to P2. Is that clear? Just by sliding this point they did it. And not only that, they allowed certain intensity of light to fall on it. Then they studied that if you consider from this graph only, you will understand it better way, that if you plot here the photoelectric current, I represent what? I is the photoelectric current, okay? And they have plotted potential difference across the x-axis. Alright, then what they have found? When it is negative potential, means maximum negative P1, is that clear? Then first of all what they have done, they have made P2 negative with respect to P1 and then slowly they increases the negativity of P1. Is that clear? Then it has been found that for certain potential the electrons started coming out. Okay, and P2, when you make it more positive, then what will happen? It will start attracting the electron coming out from the electrode P1. So when it is less positive, it is attracting less number of electron. Alright, then when you are increasing the positivity of P2 slowly, then what will happen? It will start attracting more number of electron. So when you will start attracting more number of electron, then what will happen? More number of electron will just go round the entire circuit, so the photoelectric current will increase. So you will see that the photoelectric current is increasing. Then one time will come that it has become so positive that all the electrons emitted from P1 getting attracted by P2. Then what will happen? The current will attain the saturation value. So when the current is attaining the saturation value, means when the current will attain the saturation value, when the electrode P2 attracting all the electrons emitted from P1, then the current will attain the saturation value. So let us consider that time intensity of the incident light was I. Is that clear? Now they have done what? They repeated the same experiment. Means what they are doing first? That first of all they are making P2 less positive and then slowly increasing the positivity of P2. And then the intensity, suppose it has become twice. They have taken the one incident light whose intensity is doubled. Remember, I stands for intensity. I is what? Intensity, and small I is what? Photoelectric current. This small I is what? It is photoelectric current. You must remember, don't get confused. Both are I, so that's why I have used small I here and big I here. Big I stands for the intensity of the incident light. And remember that the frequency is same in both the cases. They are having the same frequency nu. Now it has been observed that when the intensity of the incident light increases, then what happens? Again, that current will start from the same potential, but it will observe that the saturation current, it increases. Just look at this. The current is increasing, the number of electron emitted from P1 getting attracted by P2. P2 is becoming more positive. You see here, when you are going in this direction, this is the x-axis. Means what? Current is becoming more positive. So when the current is becoming more positive, then what is happening? It is attracting more and more electron. When it attracts all the electrons emitted from P1, then the current getting saturated value. But what is the observation? That is the most important part. You just see, look at the saturation current. When the intensity is doubled, intensity increases, then the saturation current also increases. Alright. So you can say that photoelectric current or the rate of emission of photoelectron is directly proportional to the intensity of the incident light. Means if you increase the intensity of the incident light, then what will happen? Photoelectric current, it will also increase. Alright. So this is the first observation from Hertz and Leonard experiment. Alright. So this graph is very important from the exam, for the exam. You may get the question like this, that plot the photoelectric current versus potential difference graph for varying intensity. So this is the way you have to draw. You have to show that potential difference plotted along x-axis, current is plotted along y-axis, and write down nu here. Nu indicates that both the incident light are having the same frequency, but the intensity varies from I2 to I. Or if you want, you can write I1 and I2 also. In that case, you must write I2 greater than I1. Is that clear? So what is the observation? mentioned that intensity means the photoelectric current, it is directly proportional to the intensity of the light. If you increase the intensity of the incident light, then what will happen? The photoelectric current or rate of emission of photoelectron increases. Alright, so this is the first observation of Hertz and Leonard experiment. I repeat, you must learn and practice the graph drawn. Is that clear? So you see, if you plot intensity of incident light versus photoelectric current, here verbally I am saying, although the this one writing part is not that much clear, so verbally I am saying, when you will note down in your copy, please note it down properly. This is photoelectric current I. Okay, along y-axis photoelectric current I is plotted. So as I said, that photoelectric current is directly proportional to the intensity of the incident light. So if you plot a graph between the photoelectric current and intensity of incident light, what will be the nature of the graph? It will be a straight line passing through the origin. So this graph also indicates the same experimental fact that photoelectric current or rate of emission of photoelectron is directly proportional to the intensity of the incident light when the frequency of the incident light is kept constant. This is the basic concept. Okay, and it's very important concept. So these two graphs you must practice. Now next, what is done? So you see, when P2 is positive, P2 is made positive, it is attracting the electron. Alright, just you consider this graph, that this is the graph we have got. So instead of going in this direction, if you just do the opposite, means instead of making P2 positive with respect to P1, if P2 is made negative with respect to P1, means you are just going in the opposite direction, then you see what is happening, the current will start decreasing, and for one negative potential, consider this potential, let it be V0, I am denoting it by V0. For this negative potential, what is happening? What is the value of the electric current? Value of the electric current is 0. What does it mean? That the negative potential of the plate P2 with respect to P1, you are making P2 negative with respect to P1. So when P2 is negative, what it will do? Will it attract the electron? No, it will not attract the electron. It will repel the electron. Because you see, electrons are coming out, but it is negative. So it will repel the electron. Then what will happen? Due to the kinetic energy of the electron, some will be able to reach P2. But if you increase the negativity of P2, then it will, one time will come that no electron will be able to reach from P1 to P2. So if no electron reaches from P1 to P2, then what will happen? The outside circuit, the current will become 0. Is that clear? Then this negative potential of P2 relative to P1, for which the photoelectric current is 0, is known as the stopping potential or cutoff potential. Now the definition of stopping potential is very, very important. So you have to write like this: the negative potential of plate P2 relative to P1, or simply you can write this way: the negative potential applied across the two electrodes for which photoelectric current is 0, photoelectric current becomes 0, is known as stopping potential. Definition of stopping potential, everybody must learn. It is also known as cutoff potential also. But mostly we use the term stopping potential. Is that clear? So you must learn the definition of stopping potential. Instead of writing the negative potential of plate P2 relative to P1, you can write the negative potential of one electrode with respect to the other electrode. Is that clear? Then also you will get the marks for this one, definition of the stopping potential. Now you see, if you consider that stopping potential is V naught, then you see what will be. You know that whenever, according to the definition of the potential, if V0 be the potential and if you consider that one electron is moving in the potential V0, then what will be the kinetic energy gained by the potential EV0, isn't it? So one can write that maximum kinetic energy EK, maximum kinetic energy of an electron is equal to EV0. You have to learn this one also, that maximum EK represent what? Maximum kinetic energy of the electron. Maximum kinetic energy of the electron is equal to EV naught. Is that clear? V naught is the stopping potential. So this is the concept of the stopping potential and the relation of stopping potential with the maximum kinetic energy of electron. EK is what? I am saying it verbally. I have not written. You must note it down in the copy. That EK represent what? EK is the maximum kinetic energy of the photoelectron. And maximum kinetic energy of the photoelectron is equal to E into V naught. What is V naught? V naught is the stopping potential. I must write here that V naught is the stopping potential. Is that clear? So this relation and the definition of potential also you are supposed to learn. Now again I am referring to that graph, current versus potential graph for varying intensity. Now look at the graph. You see, when you are changing the intensity of the incident light, then the stopping potential is not changing. Stopping potential, you see, it is same. Alright, this potential for which the photoelectric current is 0 is known as the stopping potential, isn't it? So look at the point, this point. You see, what is the current for this one? It is 0. So you can say this potential is the stopping potential. And from the graph, it is clear that stopping potential does not depend on the intensity of the light, and maximum kinetic energy of photoelectron depends on stopping potential, because already I rubbed it already, wrote and rubbed that EK is given by EV0. So one can say that as stopping potential does not depend on intensity of the light, incident light, the maximum kinetic energy of photoelectrons does not depend on intensity of the incident light. Alright, this is another very interesting finding of the Hertz and Leonard experiment, that maximum kinetic energy of photoelectrons does not depend on the intensity of the incident light. Next experiment, what was the step of the Hertz and Leonard experiment? Now they have taken the incident light of same intensity but different frequency. Alright, and it has been found that when the intensity remains the same and the frequency changes, then what happens to the graph, that the saturation current, you see here, the saturation current is remaining the same, because you know saturation current, it depends on the intensity of the light. So saturation current remains the same, but what happens to the stopping potential? The stopping potential changes. Alright, if you consider this is frequency nu1, this is nu2, when the frequency increases, then what happens? Stopping potential increases. Here in this case, nu2 is greater than nu1. When the frequency of the incident light increases, then the stopping potential increases. It means that to stop the electron coming out from the electrode P1, we need to make P2 more negative with respect to P1, or rather one can say that stopping potential, it depends on what? Frequency of the incident light. Okay, so stopping potential does not depend on the intensity of the light, incident light, but stopping potential depends on the frequency of the incident light. Alright, these are the findings. Okay, what are the 2 points you have to remember? The graph you have to remember. that what is the nature of the graph? When you are changing the frequency, stopping potential is different. But the saturation current is same, because saturation current depends on intensity and intensity is not changed in this case. Clear? And what are the 2 points we are learning from this graph? That stopping potential does not depend on the intensity of light. Stopping potential depends on the frequency of the incident light. This is the first point. What is the second point you are learning? I am not writing it, I am saying it verbally. It is your duty to note it down properly in the notebook. Okay, and what is the second point we are getting from the graph? That if the frequency of the incident light increases, then stopping potential also increases. So these are the 3 graphs. Already 3 graphs I have plotted. All the 3 graphs are important for your exam. So kindly draw it, practice it. Now, if you plot the maximum kinetic energy of the photoelectron with respect to the frequency of the incident light, then you will see that the graph will be a straight line. With a negative intercept. You see, this intercept is negative. Alright, and this point, it is known as the threshold frequency. Why it is known as the threshold frequency? Just understand it, that this is the minimum frequency of the incident light for which the photoelectric, the kinetic energy of the electron becomes 0. What does it mean? That no electrons emitted from the metal plate. Alright. Now this definition of threshold frequency is also an important part. And this graph also, EK versus nu graph, that also you must practice. So what is the threshold frequency? This is the lowest frequency of the incident light which can emit photoelectrons from a metal is known as the threshold frequency. So from this lecture, what you are supposed to prepare for your board exam, that is the circuit of the Leonard experiment, and then all the 6 graphs I have drawn, that is current versus voltage graph for constant frequency, variable intensity, then intensity versus the photoelectric current graph, then I versus V graph for constant intensity and variable frequency, which exhibits that the stopping potential depends on the frequency of the incident light, that one. And also you have to learn the graph for EK versus nu graph, okay, maximum kinetic energy versus frequency of the incident light, and the definition of stopping potential and the definition of threshold frequency. That's all for today. Thank you, girls.